You're listening to a podcast from 702 and Cape Talk.
Welcome back to 702 and Cape Talk. I'm Richard Calland. I'm the Friday stand-in. In this hour, we will have our resident doctor, Dr. Chris Smith, answering your science questions. And in the second half, you'll hear from various politicians on the subject of the local government elections. More on that, of course, in half an hour or so. If you have a question for Dr. Chris or want to share anything else with us, please get in touch. Call me on 021 446 0567 or 011 883 0702. Okay, Dr. Chris Smith, are you with us?
I hope so. Good morning.
Good morning to you. Are you well?
Yeah, I think so.
You're in London, I hear.
Good to middling. No, I'm actually in the north of England. I'm broadcasting from a hotel room using a wonderful system called IPDTL. So we're pushing the bounds of technology because we're able to use the internet and old technology, ISDN technology, to make this happen. But I've come to a conference, actually. It's a conference all about lasers.
Okay.
And there are people here demonstrating how we can use lasers for beauty treatments and what they call aesthetics. So you can do scar removal. And actually there was a person doing a presentation here yesterday on hemorrhoid treatment with lasers.
Right.
But we won't go there, perhaps.
Well, I was going to say,
that really is shining light where the sun don't shine, isn't it?
What's your tickle? Is it a scar or hemorrhoids that you're most interested in?
Well, I'm just here because I'm very interested in how this technology is being applied to medicine and other aspects of science. And I'm also being asked to speak. So I'm just here to do a sort of talk on how we make science fun and interesting. I'm on in 45 minutes. So
fantastic.
We're going to do our conversation, and then I'm going to go and talk to this bunch of laser therapists.
So I'm your warm-up act, basically, is what you're saying. I'm just going to get your voice moving, your cerebral cortex flexed, ready for what lies ahead. Whereabouts in the north of England, by the way?
Well, it's a place called Darlington, which is near Middlesbrough, which is northeast.
I know the northeast.
So we're not far from Newcastle.
Well, I did my undergraduate degree at the University of Durham, which is very much up the road.
Well, that's very close to here, yeah,
yes,
absolutely.
It is. But I also have attachment with Cambridge University these days. It's Institute for Sustainability Leadership. And I believe you're a Cambridge man too.
Yeah, that's right. So I'm actually from Queen's College at Cambridge. That's where I partly work, and the hospital in Cambridge. And I'm a member of what's called the Institute of Continuing Education. And it's quite nice because I get to go to work in a 15th century Elizabethan mansion, which is where our department is based on the outskirts of Cambridge.
Fantastic. Now, before we take callers, and as usual, they're lined up and the call screen is flashing for you, Chris, I've got my own little question, if you don't mind. Last night, my partner and I cooked beef stroganoff, and there was too much left at the end, and I wanted to propose that we stick it in the fridge and then warm it up whenever we wanted to eat it. And she argued that no, spinach, wilted spinach specifically, can't be warmed up because it will give off a particular chemical that is dangerous at that point. Is she right? Is that true? Is that warmed up spinach a danger to our health? Can you answer that one, Chris?
I've not come across that. I can't think of an obvious chemical reason why spinach warmed, heated, cooled and then reheated should be any more dangerous for you than just eating it cold. I can't imagine why there'd be any kind of chemistry going on, but that's not to say that there is. So if anyone knows a culinary or chemical reason for that, do let me know.
Excellent.
But I thought you were going to say that when we reheat food, is there a danger of doing that? And the answer is, if you keep warming and cooling food, there is a danger, because food that's taken out of a fridge, placed in an environment where it might get contaminated or colonized with microbes, the more time that food spends at a high temperature, the more likelihood there is that the microbes will grow. Some microbes grow like salmonella and then they infect you because you need a big dose of them to infect you. Other microbes, just by the sheer virtue of the fact they're growing on the food, can secrete toxins into the food. So even if you then reheat the food really thoroughly and you kill off the microbes, the toxins are stable to the heat and you then get sick anyway.
So in general, warmed up food's not a good idea, is it, basically, is what you're saying?
Well, judiciously warmed up food, that you don't keep heating it and cooling it, heating it and cooling it.
Okay.
That's bad.
Judiciously warmed up. Okay, that's a great phrase.
Judiciously warmed up food that you heat up, put it in the fridge, cool it down, next day reheat it thoroughly and then eat it. That's not going to be a problem, and it's a really good idea because it saves food wastage.
Very good. I'm taking notes as we speak. You've got calls lined up, Chris, on
Typical
the subject.
lawyer.
Yes, absolutely. I might have to hold you to account if I might sue you if I get sick at any point in the future. No, I definitely not. I won't do that. Okay, Naked Science question on uranium. and one on hemorrhoids coming up. So prepare yourself for that. It's quite a range. Alex, on the line from Orchids, you've got the question on uranium. Go ahead, please.
Yes, please. I just want to let you all know from England that I'm a Sunderland supporter.
Oh, okay.
Oh, never mind.
You must be a very relieved man in that case.
You're not kidding.
Alex.
I was sweating night to death at the end there, but they're fine. Another year up is good.
Good for you.
I need to know, what does uranium look like? How do you find it? How much it takes to run a power station? And how do you enrich it?
Well, that's a brilliant set of questions,
Right.
and there's a political edge to this,
Okay.
which I'll hold back from asking, because the Guptas are involved in uranium. But anyway, we're talking science, not politics, in this half an hour. So, Chris, over to you.
Well, uranium is a metal, and there are some places on Earth where you find uranium ore. One of the biggest suppliers of uranium is Australia. They actually sit on a huge reserve of uranium down in the south part of Australia, and you extract the uranium, and it comes in a number of different forms. There are different forms of elements called isotopes, and they differ in that some of them have extra neutrons in them that make them heavier, and so they have a number after the name of the element that tells you how heavy they are. There's a form called uranium-238, which is heavy uranium, and then there's a lighter form called uranium-235. Now, only certain forms of uranium can work in a power station, and the form we want is the 235 form, because that one has the right number of neutrons in its nucleus that it will very easily fall apart in a power station and release energy. The way you enrich the uranium, because when you find it in the ground, only a small proportion of the atoms are in the 235 form, that more of them in the 238. So what you have to do is to use what they call a centrifuge, and you can spin the atoms, and when you spin them, the heavier ones will go towards the bottom and the lighter ones will go towards the top of your tube, and this means that you can take off the lighter atoms and you'll get a richer mixture of the lighter form, and this means it will be much more easy to make that work in a power station. The actual amount of energy that you get out of a power station that runs on nuclear fuel is immense, so you don't need a very large amount of the radioactive material to make a power station work. In fact, in a big power station, like a multiple gigawatt power station, the core of the nuclear reactor, where the rods are, is only about the size of the bedroom in your house. Very, very small. The rest of the infrastructure is all the concrete and shielding to make sure the radiation doesn't come out and harm anybody.
Chris, fascinating question. Alex, does that pretty much answer your questions, or would you? I'm going to give you a quick follow-up if you like one. No, it looks like Alex is busy. So, Zane, I've got Zane on the line from Glencairn. Zane, what's your question to the Naked Scientist?
Hello?
Hello, Zane.
It's Jane speaking.
Oh, Jane. Hello,
Yeah.
Jane. Sorry, someone's typoed.
No probs. Just
welcome.
want to know, if you heat olive oil up to a high temperature, i.e. making popcorn, does it become toxic?
Okay,
Hi,
Chris.
Jane, or should I call you Zane? The answer to this is that olive oil is good for you because it contains what we call monounsaturated bonds. In an oil, there are lots of carbon atoms linked together in a chain. And in olive oil, one of those carbon atom links is a double bond. It looks like an equals sign when you draw this out instead of a single bond. And this is much healthier for you than if there's all single bonds, because all single bonds are what we call saturated fats, and we know that they seem to have a higher risk of heart disease and that kind of thing. Now, the downside here is that if you have one of those double bonds, like a olive oil, the double bond is more reactive. So the molecule is more likely to participate in other chemical reactions. When you heat it up, you give energy to the molecules and they're more likely to react. And so olive oil can turn into forms of other substance that are not good for you. So therefore, eating olive oil and cooking with olive oil at low temperature might be all right, and it's certainly good for you if it's uncooked. But when you heat it to high temperature in things like a frying pan, that's probably bad for you, and you'd probably be better off using something that isn't olive oil to do that.
The Naked Scientist is here to answer all your questions on 011-883-0702 and 021-446-0567. Return to your calls after this.
702 and Cape Talk.
The Naked Scientist.
Well, welcome back. We've got the Naked Scientist here. Chris, your next caller is Larushka from Centurion. Larushka.
Hi there. I've got a question on immunology and allergies specifically. My mom has been suffering from allergies or allergy-related illnesses for over 2 years now, but she hasn't seemed to have gotten rid of it. She's just gotten different forms of medication that seem to subdue the allergies, but they can't know specifically what is causing it and how to eradicate it completely. So I'd just like some advice on a way forward.
Chris, over to you.
How do you know it's an allergy?
Well, she's got a few sinus-related illnesses as well as some form of eczema, but it's gotten progressively worse over the past 2 years, and that's what the doctors have told her.
Fair enough. Well, as long as someone medically trained is actually involved, because that's very important, because it can often be that people assume something, they assume something is an allergy, and it might be something more serious. So it's very important that this gets looked at properly medically. Allergies are really hard to control in some people. We don't actually understand properly why they happen. We know the basics, but what we don't know is why they come on in some people, and more importantly, how to get rid of them. They appear to be a loss of what we call regulation in the immune system. Your immune system is very good at fighting things off, and there is a process in the immune system that makes sure that you only fight off the bad guys. You have this arm of your immune system which does what we call tolerance, and it recognises things that you should not react to, and it tells the part of the immune system that fights things off, you should regard this as a friend or not harmful. For some reason, in some people, this system breaks down and they then begin to react in a hostile way against things that would be completely innocuous to you, like food or things in the environment that can irritate your skin. And once you get a cycle of this inflammation set up, particularly with things like eczema, the skin becomes inflamed and damaged, and because it's inflamed and damaged, it's easier for things that are irritants to get into the skin and then make the process worse. So often the first thing to do with skin allergies and skin irritation is to try to calm the skin down, and this will encourage the skin to form a better protective barrier to the outside world, and this will stop things that that are irritants getting in and inflaming the process. But allergies are complicated. You need to start with simple things like antihistamines, which can help to reduce symptoms, and then build up to more serious things like steroid treatments to get control of the things, but this should only be done with the help of a doctor.
Thank you, Chris. We've also got, in fact, a Chris on the line for you from South Johannesburg. Chris to Chris.
Hi, good day to you. I just want to ask a question. Aircraft black boxes, is there any logical or scientific reason why they can't be designed to float in water?
What a topical, sadly, tragically
Absolutely.
topical question.
Yeah, hi, Chris. Well, first of all, the black box is a myth because they're not black. They're actually red to make them easier to spot. I suppose they could be designed to make them float, but they are designed to be extremely resilient. These things can stand being in extremely high temperature conditions, because if the plane they're in catches fire, you want to make sure that they don't get incinerated with the plane. But there's a lot of merit to having the black box stay where the plane is, because the black box has inside it location systems that send out messages that enable it to be found, and that means that if you find the black box, not only is it intact, so you've got the data from it, but also you find the plane, hopefully, or parts of the plane that it was in. And that's important too, because in order to understand what caused the accident in the first place, you need the parts of the plane, because there are clues written into that as well as into the black box as to what happened. So yes, they probably could easily be made to make them float, but A, that might not be useful because they might not be able to detach themselves and float free of the wreckage, and B, you actually want them in the context where the wreckage is, because then you've some chance of finding where the wreckage is in the first place using the locator in the black box.
Chris, you really are a marvel. But that was a very interesting and important question, given tragic events with Egypt Air. I've got Roger from Hout Bay on the line. Roger.
Hello, Chris. I want to know, can laser technology be used to purify water?
Hi, Roger. Well, there's a range of things that we want to do to clean up water. Water can be bad for you for a number of reasons. One, it can be bad for you because there are chemicals in it that have leached out of the ground. There could be metals, there could be other contaminants and toxins. In certain circumstances, laser light might be useful to clean those up because you could blast them to pieces with laser because certain molecules absorb certain colours or wavelengths of light, and that can destroy them. So it might have a use in that context. More of a threat for people around the world is access to clean drinking water that's not contaminated with bugs. The statistic is something like 5,000 deaths a day in youngsters owing to a lack of clean, fresh water because that water contains things like microorganisms, including E. coli and norovirus. And so you get a young baby will dehydrate to death because of bad diarrhea and vomiting. Now, it might be possible to use lasers of certain colours to destroy microorganisms. And in fact, researchers at the University of Cambridge and other institutions around the world have been working on making LEDs, light-emitting diodes, which emit very short wavelength radiation in the ultraviolet regime. And by irradiating water with UV, then what you can do is to break apart the genetic material in things like viruses and bacteria and fungi. And although some of the particles will still be there, the organisms will be completely inviable and incapable of causing infection. And because LEDs are very efficient and use very little energy, you can run them on solar. So using this sort of technology, which is pretty similar to how you could have laser diodes or LEDs, they're the same sort of technology, using this approach we could produce clean water and clean, safe drinking water for people particularly in resource-poor and rural areas, particularly sub-Saharan Africa.
Thank you, Chris. I've got Cynthia from Johannesburg. Cynthia, what's your question for the Naked Scientist?
Good morning, Chris, and thanks for a brilliant program. I'm 78 years old, and in the last roughly 18 months, I've got inner ear infection twice, and I just want to know what causes it. So is there anything I can do that could stave it off?
Oh, hi, Cynthia. Sorry to hear that you've had a problem. The reason we normally get ear infections is because there is a tube that connects the back of your throat to the middle ear, which is the space between the outside world where your eardrum starts and the inside part of your brain where your cochlea is that converts sound waves into brain waves. And the middle ear needs to equalise pressure, so there is this eustachian tube to the back of your throat, and it's lined by the same sorts of cells that line the back of your throat and your nose. So when we get a nasty infection, usually caused by a virus, the virus can spread along the eustachian tube. It causes inflammation in the eustachian tube, and this can clog up the tube because the tubes aren't very big. And that means that, A, you then get mucus clogging the area up, and B, you can get super infections. In other words, you get an infection that comes along on top of the virus infection caused by bacteria. And those tend to be more entrenched, more long-lived, and if they do a bit of damage and cause the tubes to be more clogged up than they would normally be, they can make you more likely to get another infection subsequently. So it might be that actually there's nothing really wrong. What's happened to you is that you've had a bit of bad luck and a succession of infections which have basically just come off one off the back of the other. But if it is persistent and it does happen again and you have any other symptoms, it's always worth going and seeking medical advice just to make sure nothing else is happening that could be picked up and treated.
Thank you, Chris. I've got Buntle from Mametlodi on the line. Buntle.
Hi. Good afternoon. I just want to find that I have a serious problem, and I've been to several doctors that done tests. I don't know whether it's an allergy or what, but they say they can't figure out what the problem is. I can't walk a distance. I can't exercise. For me to exercise, I have to drink allergens. My whole body will start itching, and for the itchiness to stop, I need to get cold water to rub my whole body with cold water.
Okay, Buntley, thank you. Chris, do you have any advice to offer?
Well, obviously we have to be very cautious about doing on-air diagnoses because it's impossible to get a very clear history and also to have a look to see what the symptoms and signs are. But if you've got something that starts itching when you exercise, obviously when you exercise you get warm, and when you get warm you can sometimes sweat, and it might be that there's something that you've got some kind of skin irritation that's happening because of sweating, and it might be a sort of thermal heat rash coming on. But beyond that, I can't really speculate because I think it'd be unsafe to do so. If this is a new thing that hasn't been happening to you for many, many years and hasn't changed, if it's something that's happened suddenly and something's changed, it's always worth seeing a doctor, because things like that can happen because of infections, they can happen because of reactions to drugs, or there could be something in the environment that's triggering itself. So it's always worth seeking some advice of someone who can see the whole picture and then put the facts in context.
Okay, thank you, Chris. And I've got, lastly, Guido from Highlands North. Guido, what's your question for the Naked Scientist?
Good morning, Chris. I would like to ask, when I travel in Johannesburg, many times I see, especially now this time of the year, that cows, I presume, get fed by hay that's derived from on either sides of highways or big roads and also the midsections. How bad is it for the cow, and how bad is it because of the heavy metals, lead, sulfur, you name it? How bad is it for the cow, and how bad is it for the milk that we drink from those cows? I'm listening.
Yeah, very interesting point. And it's certainly true that an animal which is producing a product that we're using for food and drink, whether that's milk or meat, that material coming out of the cow is the product of food going into the cow. The water it drinks, the grass it eats, the hay it consumes. And therefore, if those things are contaminated with not just lead from roads and cadmium and other things that are being churned out by vehicles, but also other things that are in the environment, that could find its way into the meat, it could find its way into the milk. And people are very worried about this, and they've begun to do trials on this, because what we're finding is that cows and other grazing animals are picking up chemicals off of the grass, and some of these chemicals can have estrogen-like effects, the female hormone estrogen. This can concentrate in the milk, and when humans drink the milk, it can then have an effect in their bodies as well. And so there's a big study going on to see if this can explain one of the observations that's been made in recent years, which is that the sperm counts of men appear to be dropping. And in some places they've halved in the last 50 years, and it might be because we're all living in a world bathed in chemicals that look a bit like estrogen and behave in our bodies like estrogen, female hormones, and this is affecting men's fertility. So it is a worry, and scientists are looking at it.
Well, that's a slightly worrying note to end this particular segment, Dr. Chris Smith. But thank you, as ever, for your brilliance and your knowledge and the way you handled all those extraordinarily varied questions. So you'll be back next week. I'm going to release you now into the warm bosom of Darlington and your conference about lasers and hemorrhoids. Good luck with all that, and thank you again for your